Whose phone is that?
That sounds like my phone.
Excuse me, could you shut your phone off?
That is my phone. It's gotta be here somewhere.
I can't believe this.
Oh. Oh, there it is.
Okay, let's see what kind of talent we can book through here today. You put this in all the trades, right?
Yeah, it's
Okay.
done.
Good. I'm gonna need a male and a female voice, and I need somebody with energy. Keep an eye open for energy, something fresh, because this stuff is like, yeah, it's dry, it's safety, you know.
Safety. It's a movie about safety?
Yeah.
Who would want to watch a movie about safety?
Very few. Here we go.
Fly me to the moon. Let me play among the stars.
Excuse me. What are you doing?
I got what it takes to be the next American Idol.
No. That audition is down the hall. Next.
Is this thing on?
Next.
Where's the dance floor? And what star is my partner?
There is no dance floor, and there are no stars.
I'll have to be careful not to trip.
No tripping, no high heels. It's a movie about safety. Next!
I am a survivor.
What?
You gotta pick me, because Survivor is my favorite show.
This is not a TV show. It's a movie.
Does anybody survive?
They all survive. It's a movie about safety. What do I have to do to get some talent?
Would you like a voice talent with that hamburger and fries? How's this? Safety. Uncover the competitive advantage.
That's the voice.
Aztec Industries, a company moving America from rock to road, building and restoring America's transportation infrastructure. It's an engaging view. Robots working at lightning speed to frame the Jeep Wrangler on a production line that is unmatched for speed and safety innovation. This is KUKA. It's a smart machine from CamOcean that uses motion control to precisely pick up and lower loads. But what's even more surprising is what happens when people and the robot try to occupy the same work location. Every year, about 260,000 Opals come off the line at this facility in Belgium, headed for over 100 destinations worldwide. Aztec, KUKA, CamOcean, Opal, they make safety a priority, and in the process are uncovering the competitive advantage.
It began some 30 years ago. Machine builders in Europe and North America experienced a huge paradigm shift with the advent of PLC technology. It changed forever the way that engineers designed and wired machines. But at the outset, the technology wasn't always reliable. So regulators on both sides of the ocean excluded PLCs from playing a role in the design and implementation of machine safeguarding systems.
In the 1970s, when PLCs came to market, it really very quickly created two layers in the architecture of a machine. The automation architecture, where a PLC would control the machine, and a separate layer of technology to do the safety and machine guarding for operator safety on the machine.
But there were no consistent standards in place for machine design safety, so it was not surprising that injuries increased. In response, workers' compensation groups from around the world began a movement calling for regulations to protect workers. Europe was the first to respond.
In Europe, we have the European directives which cover the application areas of safety-related fields. Maybe, for example, the machinery directive. But the European directives does not give any detailed measure or guideline how to fulfill the requirements. And this is done or described in European standards.
While safety in Europe was mandated and legislated, in the U.S. it continued to be viewed as something that needed to be done to comply with OSHA, a cost burden, a deterrent to productivity.
In the 80s and 90s, this rampant technology continued to explode at a very fast pace. However, the safety layer continued isolated in its own environment, and the results were that many customers were forced to choose between productivity or safety. Those that chose safety experienced a lot of intermittent downtimes with the machines, and it would have a negative impact on productivity.
Over the years, local standards emerged in different countries addressing safety and machine design. But the standards varied widely. All of that was about to change.
In the mid-1990s, spurred by shrinking trade barriers and improved technologies, the time was right for globalization and harmonization. Europe led the way.
The international standards, the IEC standard, especially the general standard IEC 61508, was a basic standard for the design, development of safety-related programmable systems. This standard was developed in international working groups.
What really happens in today's world is that compliance with regulation in any country is a given. And the higher level that you now strive for on getting common globally is conformance to harmonized standards that with risk assessment will give you what top management is asking for.
In this changing world, technology often surpasses the standards. But more recently, standards are responding with rapid change as well.
Here in the United States, the safety landscape began to change as early as 1999 with standard for robots, RIA 15.06. One of the most significant things was the risk analysis requirement that came out of that updated standard.
The second major change was NFPA 79 in 2002. Still somewhat unknown, this standard signals a major change for OEMs and end users. In the past, the standards precluded use of automation, and safety had to be hardwired. But in 2002, NFPA 79 safety standards were rewritten to be simpler. As a result, companies are moving from hardwired dedicated safety to the integrated safety PLC. Aztec Industries, based in Chattanooga, Tennessee, moves America from rock to road, building and restoring America's transportation infrastructure. For the asphalt group, times are especially demanding. Roads throughout America are crumbling because of years of inadequate maintenance. At the same time, asphalt roads have been proven cost-effective to construct and maintain, and durable. So it's no surprise that demand for new products, both here and around the world, has skyrocketed. The group manufactures portable, relocatable, and stationary asphalt plants, applying creative thinking to a traditionally low-tech industry. Mark Harnett of Aztec noticed a trend.
The CE came over from Europe, and all of a sudden we were faced with directives that we didn't understand. They were very gray, very bold, and the big part of all of it was really documentation. And all of a sudden you had to have a formal technical file that described the hazards and how you're going to protect people from it, and go into a 10 times the level of depth that we ever had to do before.
The machines which Aztec builds require a high level of safety. After all, the hazards are significant. Burns, crushing, pinch points, electrical shock, just to name a few. Up until 2 years ago, all the safety required for these complex asphalt operations translated to complex wiring from station to station, and operators had limited or no feedback from the safety relays. Aztec saw that simplification of the entire system would increase both safety and overall performance of their products.
The first thing we got into was doing distributed process control. Okay, and that was coming out with components that were shipped here from the U.S. They were pre-wired, and basically we could test as components. And we did it through Profibus. And the next thing that followed very quickly was ProfiSafe, which meant we could start to integrate safety right into the same structure and put it into the reporting of the system and make it a whole lot easier to troubleshoot than having the old hardwire system that we used to supply before.
By integrating safety, Aztec has realized some significant benefits, including cost-effective compliance, faster setup and commissioning, and extensive diagnostics.
What it really means is that we've opened up doors for our business in other countries, because if you go through and you look at like Australia, they're very, very similar to CE. Okay, it's almost a match. Japan is probably a little bit tougher even, but all the European countries and even some of the Central American countries now are conforming to using the European model as a role, and it just makes it a whole lot easier when you go in there and you can say, hey, I've got the most sophisticated control system and integrate safety and everything else with it.
In 2004, OSHA reported the fines for violations exceeded $85 million, with over 70% of them in the serious category. In 2006, OSHA identified and sent letters to more than 14,000 workplaces, urging them to take action to remove hazards. The message was consistent: do something about safety. OSHA fines are stiff and go directly to the bottom line, but experts point out that there are other considerations.
Focusing on the traditional "am I compliant" with my regulatory agencies in the U.S. may be missing the boat when I take a look at the competitive global challenges.
To be competitive, companies need to understand regulations and standards. But there are so many that it's confusing. Here's what you need to know about a few key ones to get a clearer picture of what must be done. First, at the most basic level, any machine that creates a hazard must be safeguarded to protect the operator and other employees. NFPA 79-2007 was published for distribution in October 2006. A new edition eliminates the requirement for a separate control element for the final removal of power when using a safety-certified drive. The ANSI B11 series of machine tool safety standards is another important set of standards. In fact, OSHA can assess violations referencing these and other consensus standards.
Some of the most important documents coming out are not the specific standards, but the new collaborative technical reports. ANSI Technical Report 3 is the foundation for task-based risk assessment that infuses itself through the entire family of standards. The new report being worked on for the integration of SAFE and Lean is really a seminal work.
While the standards have often been viewed as the domain of those in the health and safety area, that's changing. Today, management at all levels should know about a standard titled Occupational Health and Safety Management Systems. Approved in July 2005, ANSI AIHA Z10 is the first time in the U.S. that there's been a national consensus standard that applies to organizations of all sizes and types. Z10 provides the methodology and framework to integrate occupational health and safety into an existing management system. And the implications will be far-reaching.
If we want leaders to lead safety, then we have to put things in a language that they use on a daily basis. Z10 will help people better align what they do into the fundamental core business of any organization, because it creates a foundation for safety through design.
What's becoming obvious to many is that standards are about more than just compliance with OSHA and avoidance of fines. Standards are about doing the right thing for the health and safety of individuals, and at the same time uncovering the competitive advantage.
What industry is going to see is a flood of standards that are all in rewrite status right now. Some have just completed their updates. All of the standards are now acknowledging these new options and these new technologies with regard to fresh and new ways to think about providing operator safety on machinery.
Risk. It's all around us, every day. We all know that there's no situation that is risk-free. So when do we accept risk? And how much risk is acceptable?
Risk is acceptable under three circumstances: when it's insignificantly low, when we're sure it's worth it, and when we do not know it's there. And that's the whole point of the risk assessment.
People are drawn to risk assessment for very different reasons. Whatever the driver, one thing is becoming more and more obvious. Risk assessment works, and it takes work.
Risk assessment is really a journey. It's not an event. It's not something that you do once and you're done.
It takes time, interrupts people, 2 to 3 days on a typical machine, but after that, it gets easier and easier each time you do it.
Today, we tend to do a lot of safety work after we release the product, after we release the system. And tomorrow, what we want to get to in safety through design is getting us to the point where we're doing safety up in the design phase.
There are a number of different methods and tools available to do risk assessment, but generally the process is to identify the hazards, assess the risk, reduce the risk, and then document the results. For example, the new packaging standard that applies to both end users and suppliers of packaging machinery does not require that the level of risk is zero. It requires that risk is reduced to an acceptable level. Of course, what's acceptable is somewhat subjective, and that means you need to get comfortable with the subjectivity. In the area of machine safety, many start with the hazards of the actual machine. But Bruce Main, author of Risk Assessment, Basics and Benchmarks, discusses a slightly different and fresher approach.
One of the newer aspects of risk assessment is the task-based approach. And task-based is really where you dig down and understand what people are doing with your systems, your machinery, your designs. And it's by doing task-based that you can really identify hazards that you don't otherwise see and then reduce risks associated with those.
That's where you need to focus your efforts. Don't get hung up making it a scientific exercise. It isn't.
New tools like this software guide you through the risk assessment process. It's not an expert system. It doesn't tell you what to think, but it guides you on what to think about. So it helps you to identify users, a list of users that might be involved in your activity and the tasks that they are performing. The next level, you look at hazards, and you're able to identify then hazards associated with the tasks. Now what you get from this is a documented risk assessment that's required in the different technical standards and reports.
Sometimes hazards are designed into machines or systems. That's because the tasks are not anticipated. This occurs on both older and newer machines.
In all the years I've been doing safety and working as an engineer, I've never seen a circumstance where an engineer identified a hazard and didn't handle it appropriately. Engineers do good work. They know how to reduce risk. It's the trouble comes in when they don't identify a hazard. And that's why the task-based approach is so key, because it helps you identify hazards.
You came in to look at that laser machine. We'll have to go in the back.
Okay.
We've had the laser about 5 years. It basically has simplified our operation. It's safer than our old processes. Not only safer, but cost-effective. We've taught our employees the understanding of working smart rather than manual labor.
Well, first thing I do is look at the electromechanical devices and how it interfaces with the machine. Then I approach it from looking at the operator. What's the operator doing? How does he or she interface with that machine? Putting pallets on, taking pallets off, taking metal, handling metal. Do they have the right personal protection? It's well laid out, good lighting, good ventilation. It's well enclosed. Then I just step back and look at, is there any trip and fall hazards? Is there stacks of material around? Is there general hazards that can be removed? And any type of safeguarding that might be missing from the machine. Well, it'd be a very, very minor item, but around the edge of the machine there's a couple of eye bolts right at toe level, which could cause a trip and fall into the machine. But the eye bolts are small. They could be removed. It would remove that hazard. If I was to evaluate that risk, it'd be a 2 of 25, very low hazard.
Risk assessment does demonstrate the safety of your machines and that you have reduced risk to an acceptable level. It helps improve the machines and systems and verifies good design and acceptable risk. So why don't more companies embrace it?
Like anything else in life, the difficult things pay off the most. And safety is a difficult thing to face. You got to face it head on. That's the hardest thing for an employer to do. They'd rather, in some cases, just ignore the risk. It's easier just to put out production. The hard thing is mitigating the risk.
Documenting risk is a relatively new idea for general industry, and not everyone is comfortable in doing so yet. And there are other things to consider. Risk assessments take time, especially at first. Cost can be another factor. If a project is bid before a risk assessment is started, risk reduction measures may be needed that weren't included in the quote. That is a big reason why risk assessments need to be done early in the design process and at other critical times.
You first look at it in design stage. During design, it's easy to make changes and cost-effective to make changes, so you design safety right into the machine. Stage 2 is while the machine's being built at the original equipment manufacturer. They've got the resources and they can make changes easily. Then third is after it's been installed, so you can look at it from a pattern from that point on after installation.
Risk assessment, and more broadly, risk management, helps build a competitive advantage that will change the way you do business. It's not about theory. It's about solving real problems. And there is no quick fix. But when you understand how people interact with machinery at a deeper level, and you reduce the risk, everything is better. Better products, better operations, better business.
Running a company and having an accident-free environment is the biggest reward any corporation could have.
Safety, quality, production, cost, it's all, and morale of the employees. It's all part of a formula for a good manufacturing facility.
With all that we know in risk assessment, we know it works. We're seeing that with different companies, different organizations, standards, industries. The system works.
Let's face it, we all know that technology makes life easier. Just look around and see how industrial automation has benefited from the advances in technology. But what still remains somewhat elusive and underutilized is the technology that's making the factory floor safer. It's called ProfiSafe, and it has a tremendous impact on machine safety.
ProfiSafe is a profile of Profibus. We brought it to the marketplace in the mid-90s to capture the benefits that we saw with Profibus as we implemented these systems around the world. ProfiSafe is a proven technology. We have been installing devices for the last 10 years. We have more than 190,000 safety devices that have been installed in more than 20,000 applications worldwide.
Here's a quick look at how ProfiSafe works. In the past, you would have needed 2 separate field buses for safety and non-safety data. ProfiSafe allows the seamless communication of safety data independent of network media. A safety layer is a part of the communication protocol. Both standard and safety data are transmitted on one single cable. That reduces wiring and decreases installation time.
Most people are used to seeing the red push button. That's all they see. No one thinks about what the underlying technology is underneath there. ProfiSafe is a capability to see these devices on a network, to be able to configure these devices on a network. These are things we never had the ability to do before.
While there's always skepticism about new technologies, ProfiSafe does meet compliance requirements.
So we have now new technology in place, and with this technology we could achieve the same safety integrity as with older technology. But on the other side, this technology will give us some other benefits in view of operating, setting into operation, and maintenance.
With networked safety, you can use HMIs to literally look into or visualize the system and get a clear picture of what's happening. HMIs allow you to monitor, diagnose, and control machines. When you can locate the problem quickly, you can correct it quickly. Visualization software is available at various levels of complexity, from machine-level HMIs to scalable systems for a variety of requirements in process visualization.
With our SCADA system, we can collect that data and then we can make it available to whoever needs that information. And once we have that information, we can then start to analyze and take a look at what's occurring on the floor. So for instance, if an e-stop's been hit multiple times, why is it being hit? Is there a problem with the machine? Do we need to train the operator better? We can make these better decisions because all that information is being pulled into the HMI. One of the biggest trends that we're seeing in visualization is increased mobility, whether that's on a wired mobile panel or it's on a wireless mobile pad.
By combining safety level and standard automation into one total system, one standard bus, and employing HMIs, there are benefits. For OEMs, it's the ability to cost-effectively and quickly respond to customer requirements. For end users, it's the ability to upgrade and modernize existing machines, plants, and systems to state-of-the-art safety technology.
Located in Belgium, Opel's 5,200 employees work together to produce an average of 260,000 cars per year. Whenever people and machines come in contact, it's potentially dangerous, and safety must be a top priority. At Opel, it is. That's why they identified a new robotic arm, cages, light curtains, and other safety devices like e-stops to add to their existing control system. Unfortunately, their traditional safety relay methods couldn't accommodate all these new safety devices. One look at the countless wires snaking through the system, and that was very clear. To make matters worse, updating the system would be cost prohibitive and technically very difficult. Opel needed to simplify safety. They needed small, decentralized safety I/O modules to eliminate long independent wire runs. They needed a safety system that would work with their existing system. They needed integrated safety, not a separate hardwired safety system. Opel chose a single safety-rated PLC that performs all their usual automation functions as well as fail-safe operations that before required a separate hardwire safety system. The new solution is housed all in one single efficient package that is networked to the safety devices. The advantages of this single safety PLC are many: shorter and fewer cables, easy integration with the automation control, flexible network solutions, easier maintenance, and finally, increased production. By combining safety and automation, Opel has increased production, and its 5,200 employees are, without question, safer.
When it comes to technology, you have choices. So you might wonder, how much technology do you really need? At the most basic level, there are dedicated safety relays. These relay systems perform simple diagnostics and are hardwired back to the PLC. It's a great choice when the amount of safety points you need are small in number and functionality. Next is OSI. It's the lowest cost and easiest to use network that combines standard sensors, actuators, and safety field devices. Built on an industry standard specification with 300 worldwide vendors. But what happens when your operation becomes more complex? And how do you know when it's time to consider simplifying safety? Well, if this looks familiar, the answer is right now. Of course, every operation is unique, so here's a quick test to help you decide if it's time to automate. How much machine downtime do you have that is safety related each week?
Any downtime is too much downtime. But if you're experiencing periodic downtime caused by your safety system, it really is time to rethink designing your safety on that machine. And in many cases, just a couple of hours of downtime will more than pay for a complete safety upgrade. And if you take that design into your next machine design cycle, it costs even less.
When you have a breakdown, can you easily locate the problem?
If your operator has to walk the entire machine looking for the cause of a shutdown, you're losing valuable production time. With integrated safety, we can pinpoint the cause of that fault, put it on the HMI screen, give your operator the exact information he needs to solve the problem, and get your machine back into production.
What kind of problems do you have maintaining your traditional safety system?
You know, it's not uncommon to find yourself all alone when the system indicates that the problem's in the safety circuit. You got your ohm meter out there, you got these wires that seem to go everywhere and nowhere all at the same time. You can't figure out which device has failed. On the other hand, you could put in a safety PLC with safety integrated that will lead you right to the problem, help you solve the errors, and make you the hero instead of the goat.
How much safety coverage do you really need compared to what you have today?
You know, every application's not going to benefit from safety integrated. If your machine's about the size of a conference room table, you're probably not going to want to move into safety integrated. But as your machine grows and the number of safety functions you need to implement increase, your traditional safety functions are probably not going to be enough.
Do safety issues sometimes shut down the entire machine, when logically a large part of it could continue running?
With safety integrated, you have the flexibility to easily program independent stop zones so that only a minimal part of the machine is down.
What's the cost of adding safety devices? And how easily is this accomplished?
Just think about the amount of time it takes to install wire, electromechanical contactors, safety relays, and coordinate all these things together electrically. Today, we simplify it by programming the safety functions in ladder logic software, just like we do with automation control, and we reduce the amount of wiring, reduce the installation time, and create programmable safety.
What does integrated safety do for me?
Ease of use, ease of reconfigurability. It gives you the flexibility of reasonable code and design. So, for the same reasons that everyone started using PLCs in the 1970s, now safety PLCs are becoming the standard, making safety simpler than ever before.
KUKA Flexible Production Systems is one of the leading producers of automated robotic production systems for car bodies and chassis. They are innovative and forward-thinking. That's why they were approached and won a Tier 1 contract from Daimler Chrysler. To design a superior body shop to produce the body in white for the Jeep Wrangler, KUKA needed to put all its knowledge and expertise to work. To begin, they knew they had to streamline their traditional hardwired safety systems with large panels and endless relays and reduce costs. What they didn't know was that the safety landscape of the North American market changed in their favor.
So investigating with Siemens, they introduced me to a specification that had changed, which is NFPA. And what surprised us about NFPA, the change in there, is where you no longer had to have hardwire relays for safeties.
The body in white application is complicated. Using traditional hardwired safety would have been expensive to install, troubleshoot, and maintain. And hardwiring would make changes and modifications difficult and costly. The chosen solution had to utilize field-proven technology, provide substantial cost savings, manufacturing flexibility, mean time to repair, and at the same time improve system safety.
Our biggest priority was safety for our employees. Typically our customer specs the safety requirements. In this particular environment, KUKA was responsible for the safety.
KUKA chose a solution that combined machine safety and standard machine control on one field bus and addressed other critical issues, like modular design, which reduced the size and footprint of the cell by over 15%, saving valuable floor space, and point-level diagnostics.
Normally you would allow, let's say, 3 to 5 days to power up a system, like this one here. With the new technology, the modular design, it took us 2 hours to power up a complete system here. That shocked us completely. With these safety PLCs that we're utilizing here in the network, with the fast scan time, we feel confident we're able to protect the operator better. We're able to integrate more robots now with operators.
The benefits of the KUKA safety network are both immediate and long-term. At the outset, it saved engineering hours, valuable floor space, and reduced the machine safety components by 85%. Installation time was reduced, and labor savings totaled 30 to 35%. In the long term, the built-in diagnostics pinpoint a problem and display it on an HMI, This eliminates extensive troubleshooting when a fault or machine stop occurs.
When there is a situation out there, I can tell you within meters, feet, or inches where that problem is, whereas before we never had diagnostics, point-level diagnostics like that.
And because the code is now software-based, any line changes, addition of new equipment, or expansion to the design is easily accommodated, and flexibility is enhanced.
Based on our experience, our customer, Daimler Chrysler, has adopted the safety PLC architecture we developed here for all future programs. We're currently building 2 future body shops that will have this safety PLC architecture in place, which is very similar to the architecture we have in operation today. In this environment was a $3 million savings.
The technology is proven, the cost savings substantial. Couple that with increased machine safety, and the case for integrated safety is clear and compelling. Material handling often requires palletizing and depalletizing. If done manually, the process is slow, labor-intensive, and contributes to repetitive stress injuries. But accurately picking up and placing products of different sizes remains difficult. A customer challenged Camotion, an OEM and integrator, to take its feeder line to a whole new level. That's why gantry robots are a desirable solution. At the outset, the goal was to eliminate any repetitive motion activities on the line. There were numerous material feeders that were manually loaded by operators. To meet demanding production requirements, Camotion, along with Siemens, developed a solution for safety that combined the accuracy of vision systems with wireless controls. The result is a system that is dramatically safer and more productive.
The customer was looking for a system that was fully automatic, that was an open design, no physical barriers, would work hand in hand with their operators.
Camotion's gantry robot operates on rails 20 feet apart, spanning 150 feet. A video-based motion control system is trained to accept a wide range of variables in the environment. Products that are misaligned, pallets that are not squared to the production line. Loads are precisely picked up and lowered into position. The safety perimeter is electronically managed, dynamic, and changes rapidly through the production cycle. No fencing or other physical barriers are required.
Literally everything that you're seeing transpire in this system is done in real time. It's 100% vision guided, and it uses no hard locations that are typically taught with traditional robotics.
One area where you can see the difference between the older manual method of operation and the new solution is in the cabling. What makes the difference is wireless. The control system for the entire system runs through a wireless Ethernet network that updates safety and operational information nearly 1,000 times a second. This type of real-time requirement could only be met by using Profinet as the industrial Ethernet solution. The ability to run all plant communications on a single wireless network delivers many business advantages as well.
This system needed to be scalable to go into a variety of different plants, and it needs to be set up for a line any given day for any given job.
Using wireless to combine safety and operational information in one network is more cost-effective. Engineering is simplified. Fewer cables means less breakage. Maintenance is reduced, and so is downtime. And upgrading the technology is dramatically easier. The customer had 2 objectives: safety and reducing costs. Camotion was able to achieve both.
There is no doubt that many U.S. companies are experiencing a cultural change when it comes to safety. In the past, it was viewed as a burden. Today, it's an opportunity to provide a safer environment for workers and improve the bottom line. Liberty Mutual was at the forefront of the earliest work on machine safeguarding. Today, groundbreaking research continues at the Liberty Mutual Research Institute for Safety.
Much of our earlier work was on acute traumatic injury, which included machine injuries during the Industrial Revolution. And some of that early research has become worldwide machine safety standards.
According to research, the ranking of the top 10 causes of disabling workplace injuries include being struck by moving objects or being caught in or compressed by moving machinery. Both are significant when we look at machine safety.
Overall trends in the frequency of injuries in this country has been declining for a few decades now. However, the trend in frequency of the more severely disabling injury has not declined as much. And the cost of work injuries is actually escalating due to medical inflation and wage inflation.
The Bureau of Labor Statistics reports that the manufacturing sector's frequency rate is about 40% higher than all industry in this country. That has a huge impact on costs.
The cost to the business is the lost wage replacement and the medical cost, which is really a burden of the employer. Regardless of the insurance mechanism, the employer ultimately pays the cost of those injuries.
But the total economic burden must include indirect or hidden costs.
About 3 to 5 times the direct cost is the indirect cost: damaged equipment, damaged product, lost productivity, replacement workers.
And that's where the opportunity lies. When you move from safety as an afterthought to safety by design, it pays big benefits.
From a cost standpoint, it's just way better than the traditional methods we used in the past.
Product improvements, productivity improvements, better insurance rates. There's just a lot of things that come out of this.
And it's good for the reputation of your company, it's good for your stakeholders, it's good for your stockholders, it's good for your customers.
Today, safety is about more than just compliance, more than avoidance of fines. It's about safety by design. Companies that use risk assessment to understand the complexities of how people interact with machines, minimize the risk, and maximize the benefits. Aztec, Opel, KUKA, Camotion. Safety. It's time to uncover the competitive advantage.
God, I feel like it's gone on forever.
I like the goat better because the Lone Ranger is a hero already.
Is there anything else you want to tell me?
I need a raised mic.
No.
Cut.
Cut.
That was weak.
You're losing valuable downtime. Yeah, valuable downtime.
Natural.
I think what's happened is, I forget.
Look at it, yeah.
And I lost my train of thought.
What's my name?
I can't do this. I hate this. I don't want to be a movie maker.
My boss will probably tell you the same thing, I hope.
Okay.
Is that good?